Welcome to ASOC Tutorials India program to learn amateur radio in India. And same time, I just want to say my tutorials are not made for any kind of entrance test. So first recap, remember all previous session, whatever I had taken, because my session is continue to radio receiver and now it is communication receiver. So whatever you have learned till previous sessions, keep it in your mind and remember one by one. First, antenna. The function of antenna is to receive the electromagnetic wave from ionosphere and convert the electrical waves and vice versa for transmitter. Second stage is RF amplifier plus tuner. The word amplifier will amplify or RF amplifier will amplify the RF signals plus tuner. This tuner will select the desired channel, frequency and band, and same time we need a local oscillator. If you remember, in super heterodyne receiver the IF frequency was 455 kilohertz, but here because now it is a communication receiver we are going to repeat two stages, two levels. So first oscillator is 2000 kilohertz, or I can say 2 megahertz for a traditional general communication receiver. Now we have a mixer. After the mixer we have available frequency is 2000 kilohertz. This 2000 kilohertz will be amplified in IF amplifier stage. Listen carefully. Now because it is a communication receiver we need more selectivity, so we need more filter circuits, we need additional stage of another mixer, second mixer. Now 2000 kilohertz is coming to the second mixer. Same time local oscillator 2 is also creating higher frequency which is fixed 2200 kilohertz, so that we have 200 kilohertz as a output. This 200 kilohertz is lower than super heterodyne receiver which is 455 kilohertz. So more narrower band means more selectivity. So now we have 200 kilohertz signal, and this IF amplifier will increase the strength of this signal also. Next stage is AGC. This AGC is getting signal after IF amplifier 2, and this one is sensing the strength of the signal on the base of strength. If signal is strong enough, it will send back a signal to the RF amplifier and IF amplifier and saying to reduce your gain. If signal is weak enough, then it will send a signal to increase the gain. Result, we will get a constant output so that there is no variation, and this is everything due to AGC section. Once AGC section work is performed and we have smooth signal, this signal will go to detector or demodulator stage. In communication receiver, in traditional communication receiver, the main aim is to detect various kind of signal. This may be AM radio, FM radio, single sideband. In even Morse code, if we have a Morse code, we need an additional stage BFO. This BFO is very much needed to decode continuous or Morse code. And of course, squelch is also very important to, if there is no signal, to eliminate noise from the audio stage or to save the energy. This squelch circuit is very much needed. Everything already explained in previous slides. Kindly go through previous sessions. Now going in details to the detector or demodulator stage, because after the output of detector and demodulator stage will go to the audio amplifier. So audio amplifier I will discuss later. First come back to the detector or demodulator stage. How this one is working, let us have some brief in details. Not so much formulas, just a simple view. First recap. AM detector. diode detector. This is simplest and easiest form of detector used for AM demodulation. Already it has explained, and this detector consists of diode and low pass filter. Low pass filter means one capacitor and one resistance, and same resistance is using as a variable control also, so that you will get a smooth as per required volume. Go previous session. But here I want to clarify once again that this AM waves or waves is applied as an input to the detector, and in rectifying the RF signal, the AM diode, generally I remember OA79, provide an output equivalent to the envelopes of one half of the signal. In view of this operation, the diode detector, it may sometimes be referred as a envelope detector. Why I am saying? Because if in examination, examiner may ask, what is envelope detector or envelope detector detect AM, then answer you must know that envelope detector is AM detector. Just to clarify, I had taken few lines, and this diode envelope detector rectify the waveform, leaving only what? Just a positive half, because it is diode, it will give you forward bias. But this is a pulsative form. What to do with pulsative form? We have to fill it. This high frequency eliminate, we have to remove it. We will do a capacitor, and later part a resistance, mostly variable resistance or potentiometer or control. This will work as a volume control, and this volume control is suitable audio or volume level will give to the further stage, that is audio amplifier. That is just repetition only for AM receiver, which is one of the simplest form. But when we are coming to the communication receiver, just AM is not enough. We have so many modes in traditional communication receiver. So this is a just waveform, just to remember how it is converted and how you will get the output. Going next level so that you can understand it. This is AM only. Now we need FM also, but FM is slightly complicated, but some terms you have to remember. What terms you have to remember? First, FM modulator or team or detector is also called FM discrimination. Objective question may ask FM discrimination word, then don't confuse, so they are same. This is a key process in the reception of FM signal. To demodulate FM, it is necessary to convert the frequency variation into voltage variation. This is very important, this line. Why? Because AM detector, in AM information is available in amplitudes. Just detect amplitude and get the signal, but when it is coming to the FM, there is a variation in frequency, and this variation of frequency we had to convert to voltage variation, and this voltage variation is our audio terms, audio nodes. How this one we have to do? There are several techniques, so many techniques we have. Slope detection. The selectivity curve of the ratio is not linear but have distortion. This is one of the oldest technique. Ratio detector. Ratio detectors need a expensive transformer and have a third winding. It is also part of look like a transformer to produce an additional signal, which was phase shifted for the demodulating process. The ratio detector used two diodes along with a few resistance and capacitor. And third one is Foster-Cille FM. It is very similar to radio detector. Instead of using a third winding in the transformer, a separate choke is used to develop voltage across a choke. Almost same. And there is a one more technique, phase locked loop demodulation. This is very famous nowadays, very important, and have so many features and give excellence performance. Even we can create an IC also, but I have not seen examiner is asking about PLL. And one more detector technique is there, quadrature detector. It is coincidence from a FM demodulator. It is easily incorporated into an IC and can be added with virtually no additional cost. But here in communication receivers FM like walkie-talkie and others, it is used. But my intention is of ASOC examination and syllabus is very old, so I had to cover only basic traditional education. So going continue, just trying to explain how FM detector works. Here listen carefully. Just see a simple diagram concept. How I am taking a signal after IF amplifier feeding to transformer and capacitor is used to stop RF higher level of RF spikes so that RF should not come, only IF go. And once we have a signal in transformer, this circuit will work as a FM detector, and this is one of the example of Foster Series circuit which is using phase difference between signal. If there is no change in phase difference, the output will be same in both diode, result will be zero. And this capacitor in secondary side, if you see carefully, this will just going to create 90-degree out of phase, so that there is something. And one C3 capacitor is also provided just to protect feedback. And RF choke is very important. It resembles the circuit of a full wave bridge rectifier style, the format that uses center tap transformer, but additional components are added to give it a frequency sensitive aspect. Now this circuit is frequency sensitive. The basic operation of the circuit work on the instant. Instant means instant value of AC, because it is fluctuating, it is changing. On the base of these instant values, the output of two half tuned transformer that produce, if frequency is not changing, it is same, result is zero. But if frequency is fluctuating, result will be different, not same, and difference voltage will be come out, and that is only our requirement. The difference frequency will be develop some voltage. And if the frequency is changing, already I had told you, this deviation of frequency is our requirement. To obtain the difference phase signal, a connection is made to the primary side of the transformer using a capacitor C, already I shown you, and is taken to the center tap, and this gives a signal that a 90-degree out of phase. To create 90-degree difference, this is just used. When an unmodulated carrier is present at the center frequency, both diode conducts to produce equal and opposite voltage across their respective load resistance R1 and R2. These voltage cancel each other, so there is no voltage because frequency is same. As the carrier moves to one side of the center frequency, means it is going upside or downside, and balance condition will be distorted. It will disturb, and one diode conduct more than other, so there will be different voltage, and this different voltage is very important. This result in the voltage across the resistance being larger than the other, and the resulting voltage at the output corresponding to the modulation on the incoming signal. And the choke, RF choke, is required in the circuit to ensure that no RF signal appear at the output. To stop RF signal, this is used, and AF signal will only bypass, and the C1 and C2 will work as a filter circuit after a diode to eliminate RF or filling the RF pulse or spikes. Result more linear output of lower distortion audio output is available, and this audio output will go to the AF amplifier. This is FM detection technique as a sample, not going to discuss other parameters. Going next. Now the parameter is continue waves or SSB. They are almost similar, just basic info only I am giving to you. You know, we radio amateur, also called ham, use Morse code or CW, and also to save energy we are using single side band or lower side band or upper side band. Lower side band, upper side individually they call single side band, not AM. Why? To save energy, and we want a long distance communication. So we are using it information transmitting using a radio telegraphic key, Morse key. And what is our process? Just we are switching it. It is just a switch which is just putting it on off, or we are just producing a long or short period of radio waves. This waves Morse code later at receiver end spell out as a text message, and this text message is in the form of Morse code. If you don't know Morse code, already I have my series Learn Morse code in 10 days. You go and learn Morse code. But for restricted grade, Morse code is not required. This Morse code is required only for general grade in India. So, but you have to learn this concept also, because this is part of communication receiver. And so radio receiver had only to distinguish between the presence or absence of radio signal in case of Morse code. So the CW modulation or Morse code modulation is a process of what? Transforming a baseband signal message, it is a Morse code, to another signal called modulated waveform in audio tone, so that you can listen and decode it. To recovering the baseband signal from the modulated waveform or shifting to another frequency, we use BFO, beat frequency oscillator. Listen carefully. It is very sensitive, a very important topic in communication receiver. This BFO or beat frequency oscillator is what? It is also a free running oscillator like other local oscillator. The difference is local oscillator, first one is depend on incoming frequency, second one is fixed, and these local oscillators are just to bring down RF frequency to IF frequency. But this BFO oscillator is to convert this Morse code signal to audio tone, so that we can listen and decode the message. And RF oscillator, this will generating a radio frequency signal of fixed frequency. The other oscillator generate a frequency of variable frequency, and this value is somewhat difference of that of generating fixed frequency. Means if we want to listen 700 hertz, 600 hertz or 750 hertz audio tone, and this will be the output of difference of two frequencies. Which two frequency? One IF frequency coming as a RF, and one is our oscillator generated, BFO generated, and difference is audio tone. And these two generator frequency, fx and fy, they are going to mixer. Mixer means this is itself, and the producer sum and difference of two frequency, and they are input. The mixer present in the circuit of BFO, BFO itself is a mixer, is adjusted in a manner that the produced difference frequency at its output will be at the audio frequency range, and repeated sayings again and again. The output after BFO in detector stage will be audio frequency, audio Morse code tone. And RF filter, this suppress all other RF component except the difference of two frequency audio tone. So there is a filter also to eliminate other than audio frequencies. Now the produced signal, which is an audio frequency, is fed to the AF amplifier for amplification, and previous and further stage are same. Where is the difference? Only and only in detector stage. So I am continue in detector stage. And here one thing you have to remember, stability in the BF is a very important factor. If you are not able to maintain its stability, then there is a different in tone, and result it will look like a music, and we will face a problem to decode it. So stability is a very important factor for CW receiver. Now coming back again to block diagram of communication receiver, remember everything. Now we have a detected signal. Now this detector signal will go to audio amplifier. Here it is very important for you to understand audio amplifier, but you will not understand unless you have seen my previous sessions on amplifier. So one time you have to understand basic of amplifier, how class A, B, ABC amplifier, even push-pull amplifier, because everything is required to us, type of amplifier required to us. So coming back on an amplifier, first remember there is a need of pre-amplifier stages to increase the voltage elements. In this kind of amplifier is mostly used in pre-stages, and this audio amplifier is pre-stages. Once we have improved this pre-amplifier stages, we need a power amplifier, maybe class B, AB or C. So this one is a class B amplifier. This class B amplifier is the next level for power audio amplifier, and we have to combine them. Now this combined set is working as a one complete audio amplifier. Even if you need to get bass treble, you can add equalizer also, but they are separate issues, separate time. So after this one, coming back on the stage, you have to understand power amplifier. So everything I can't explain you in single video. You have to go step by step. This is my communication receiver, and once you have this audio input signal, it will go to the loudspeaker. Loudspeaker is also a very separate topic. How loudspeaker is working, how it converting electrical signal to acoustic wave or sound wave, I will cover separately, because it is needed to understand. And same time, when you are understanding speaker, it is also important to understand microphone, how microphone is working. It is reverse of speaker. So this is not an end of my today's session or receiver. My topics continue. Unless you understand speaker and microphone, you can't go ahead. Why microphone? For the transmitter. Why speaker? For the receiver. And both required for two-way communication. Communication receiver means transmitter and receiver both. And what I had taken only receiver part. What is pending? Communication part, transmitting part. So my topic is still continue. So thanks. Hope today's session is giving so many information to you, and I hope this is good for you. If you really like it, kindly press the like button and subscribe to my channel. And this is continue the communication receiver. Now see you in next part. Have a nice day. Good day.